So welcome back to Embedded Systems 2, and in this particular short video I'm going to be looking at how we interface or connect a digital to analog converter to a PIC16F84 microcontroller. Now, a digital to analog converter will take a digital signal, logic 1s and 0s in other words, and convert it into an analog signal. The digital analog converter I'm looking at in this slide is the AD557, or the Analog Devices 557, an old-fashioned 8-bit simple digital analog converter. This digital analog converter has 8 data lines called D0, D1, D2, D3, D4, D5, D6 and D7. And those data lines are pins numbers 1, 2, 3, 4, 5, 6, 7 and 8 of the AD557. So we've got 8 pins on this analog to digital, on this digital to analog converter, and those 8 pins can be sent logic 1s, as shown here, or logic 0s, or any combination between 0 and 255 to the digital to analog converter. You can see that D0 to D7 are connected to port B0, port B1, port B2, port B3, port B4, port B5, port B6 and port B7 of the PIC microcontroller. So we have an 8-bit output port here. We're connecting it to the 8 data lines of the digital analog converter. So what we're going to do is we're going to transfer, let's say, 8 logic 1s from the port B register inside the PIC microcontroller out onto the port B lines, here they are outside on the port B lines here, to the analog to digital converter, and that's going to generate a 2.5 volts output voltage here. That's an analog output voltage. And if I change any of these logic 1s to a logic 0, this analog voltage will change. So this is a low-cost device, it's an 8-bit device, and as I send 1s and 0s to it, the output voltage here changes between 0 and 2.55 volts. Now it's important we wire this analog to digital converter correctly. So we've got 2 control lines called chip select and chip enable. We need to tie them to ground. We've got 2 ground pins. We need to tie them to ground. We've got a power pin. We need to tie it to power. And then we've got 3 analog output pins which you need to tie together, and that'll give me an analog output. So if you like, pins 1 to 8 have to be directly wired, port BB to port B7. Pins 8 and 12 have to be grounded. Pin 11 has to be tied to plus 5 volts. Pins 9 and 10 also have to be grounded. And then pins 14, 15 and 16 have to be wired together to generate the analog output voltage. So that's the analog to digital converter that we're going to interface to the port B lines of the PIC microcontrollers in labs. And we look more about how this is actually going to be carried out and done when we actually carry out this lab exercise. Thanks for listening. That's the end of this video.